Good morning. We are Team 17 and we will be presenting on detecting insincere questions on question answer platforms. Handling toxic questions is a burning problem for every question answer platform. The questions that don't seek information but rather make statements, spread false information founded upon false premises, or attack a group of people are deemed insincere. Such questions need to be removed so that users can feel safe while sharing knowledge. The main aim of our study is that given a question, we need to classify whether it is insincere or not. The main difficulty in detecting insincere questions is that the language used varies by the region and the people. Thus, the solution is not to merely build a list of stop words and remove them. For example, why do black people have black faces, and how can I remove blackheads from my face? Both these questions employ similar words, but their usage is completely different, with the former being an insincere question. The dataset that we used for our project is the Quora Insincere Questions Classification found on Kaggle. The training data consists of 3 columns: the question ID, the question text, and the target of the question, with 0 being sincere and 1 being insincere. There are about 1.3 million questions in the training data and 0.3 million questions in the testing data. There is extreme imbalance observed in the training data set, as 1.2 million there are 1.2 million sincere questions versus only 80,000 insincere questions. Thus, there are only 6% of the training data that consists of sincere questions. A sample of the sincere and insincere questions has been given below.
Now we'll move on to data pre-processing section. So our approach consists of 3 primary steps, in which the first is the data pre-processing. The first task in pre-processing is to remove the HTML links and replace them with a URL tag. We remove these links because they only support the words in the question and they don't need to be passed. We also remove the punctuations because they do not contribute to the sentence structure, which can already be derived by the conjunctions and prepositions. We also perform the lemmatization step, in which we reduce the words to their root forms. For example, playing becomes play. Here you can see an example on a sample question from the dataset. Note that we do not remove the stop words like and, the, for, of, because these contribute to the sentence meaning, and hence that is what we are trying to learn. The next part is the embeddings. So we use a glove embedding model, which is an unsupervised algorithm that obtains vectors from words based on a global word-to-word co-occurrence matrix. It projects the word into vector space such that similar words are closer to each other. As you can see, vector of king minus man plus the vector of woman becomes a vector of queen. So glove is very good at handling such analogies. Due to resource constraints, we use a Wikipedia 2014 corpus with 6 billion tokens, and the words are represented in a 100-dimensional vector. The next step in our approach is the bidirectional LSTM cell. So bi-LSTM is a special variant of LSTM in which there are 2 layers. The forward layer works on the sentence in the forward sequence, whereas the backward layer processes the sentence in a reverse manner. At each time step t, the hidden state in the forward layer corresponds to the information gained from the past words, and the backward layer hidden state corresponds to the information gained from the future words. Concatenating both these informations is important in capturing the complete meaning of the sentence. So next, let's look at the block diagram of the approach. We have the question, it is pre-processed, then we map each word to its vector using the pre-trained glove. So if there are n words in the question, this will output a n cross 100 matrix. Then we truncate or pad each sentence matrix with 0 vectors in order to make it to a fixed length of 32. If there are less words, we'll pad. If there are more words, we'll truncate it. The matrix is passed to the bi-LSTM cell, where we concatenate the information from each of the 32 time step LSTM cells, pass them through 2 dense layers, and finally the output is a probability, which denotes whether the question is insincere. Now, my friend will take over the model selection section.
For model selection, we initially fixed our architecture with 128 units of RNN cells and trained our model over 10 epochs with a default ADAM optimizer. We tried 3 different RNN architectures, namely GRU, LSTM, and bi-LSTM. In our findings, we found that the bi-LSTM gave us the best validation accuracy and validation F1 score. After that, we fixed our model architecture to bi-LSTM. Once we fixed the architecture, we carried out the model selection and hyperparameter tuning. Initially, we did the hyperparameter tuning of the batch size, where we found that 128 was the best batch size. So we changed our batch size from initially 64 to 128. Then we moved on to finding the best number of LSTM units, where we found that the 128 LSTM units which we had kept by default were the best, gave us the best validation loss and F1 score. And similar was the case for learning rate as well. Increasing or decreasing the learning rate did not improve our validation loss and F1 score. Here we can see the results of our final model, which consisted of the GLOW 100 dimensional vectors and BiLSTM with 128 units, two fully connected layers with 32 neurons and an output of sigmoid. Here we can see that we found our best training loss and best validation loss and best validation F1 score at the 8th epoch, after which it started increasing. So that's where we stopped the training. Here we can see the classification report of our model. Here class 0 denotes the sincere questions and class 1 denotes the insincere questions. Since we do not have labels for the test data, we use 20% of our training data as our to report our metrics. Here we can see that the best F1 score that we got for our model was 0.67, and the recall for class 1 was 0.91. We determined that recall was more important than precision, as we wanted to flag the maximum number of possible insincere questions, as we thought that after flagging them, a moderator will take a look at them. So the recall was more important. While comparing with our baseline, we built our own baseline model where we did TF-IDF vectorizing of the words, and then we passed those vector embeddings through an SVM classifier. We received an F1 score of 0.50 in that, and our best model achieved an F1 score of 0.67, which was an improvement. We can see from the confusion matrices of the baseline approach and the final approach that the false negatives are more in the baseline approach than the final approach. We managed to reduce those. So we can say that there was definitely an improvement. These are the references. Thank you.